Given a lesson at 44. Hello! Hey guys! How's it going? I'm really hoping you guys are going to be there. Hope so. I'm just tracking down my next video. There we go. Make sure that that's paused. There we go. Chat is disabled for this live stream. Why? Why? Why is my chat disabled? Uh-oh. That's strange. Oh, hang on. No. I've clicked on the wrong one. Refresh. Sorry. Are you guys there? Let's do that. Comments on. Sorry, guys. Hey, we're there. Finally. There we go. Found it. Oh, sorry. I overran on my year 11 webinar, and so I'm a bit late. Sorry about that, guys. So nice to see you, everybody. Happy Monday. And guys, moles part 3. More moles. I love moles. Okay, I need to register. Hang on a sec. I need to pause that. Stupid. The laptop. Hang on. Do you know what? We're running late. I'm having a mare. There we go. Right, who've I got? I've got Lynn. Have I got Amani? No. Have I got Zach? Where's Zach? Slate. Man, where is everybody? Got Dom. I've got Ryan. Anyone seen Ryan? I've got Lynn. I've got Libby. Yep. Got Helping. Got Caitlin. Yep. Got Caitlin. And Anya? Yeah, and Anya's in. Who else? I've got Laura. Yay, there's Laura. Laura's there. Where's Laura? Laura's not meant to be in this webinar. Oh, no, there she is. Found yet. My bad. Dom. I've got Dom. Where's everyone else? Where's Dom? Have I marked you off? Oh, Dom, I've already marked you in. Sheesh. Lynn. Done, Lynn. How are you getting on? Amani, Kayla, Sophia, Zach, Mason. Zach's in. Sophia's in. Yeah. Tiffany. Has anyone seen Tiffany? Mel, Audra. Where are they? God. Hey, yo. Love that. Sup? What's up, Zach? What's up, Tiffany? Whoop. There we go. There's Tiffany. Smashing out. Winner. Anyone else? Anybody else? We're looking for Atia. Do I have Atia? I feel like I may have seen Atia. No. Damn. No Atia yet? I'm calling Mel. Good job. Oh, thanks, Tiffany. You're such a star. You really are. You're fab. You guys are always so supportive of me. You guys are great. Swag time. I don't know what that is. Man, wrong channel. I know, right? Definitely. I don't think I was meant to read that either, was I? Damn, Atia. Oh, you just embarrassed me. Has anyone seen Ryan? Or Audra? Anybody? Mel? No? All right. Well, I'm going to leave it there. I realize it does take me a good while to get the register all done. How long have I been streaming for now? A good 4 minutes. Audra is here. Way okay. All right, I'm on it. There we go. Audra's in. What about? I'm missing Mel. That's it. Just Mel. Anyone seen Mel? Yo, Mel. What's up? What's up? I've lost my mind. I've got pure cabin fever. Lost my mind. But it's okay, because moles are going to sort me out shortly. Yeah? So, no, Mel. I'm giving up. Mel, done. Oh, no! She just arrived. Oh, man. Oh, you just scraped in. Scraped in. Cool. Right, guys. Let's do some moles. Okay, share screen. Share. That one. Hide. There we go. We're up. Cool. Right. So, last lesson, we did moles in solution, and I set you guys a homework. So let's go through the homework first of all. First thing we need to do is we need to, by the way, our title for today's lesson is going to be moles in gases, but you don't need to worry about that quite yet. Let's just quickly go through the homework first of all. I kept reloading it, but it didn't appear. Sure. So I set you guys moles in solution homework. Yay! So let's go through this. And the great thing was, it essentially was just getting you to use, I hate this, by the way. No, I hate it. I'm looking at it as sitting, no. I hate triangles. I hate them. Anyway, so let's go through our answers. You guys can tick them off as you've done them. So we've got number of moles equals C times V over 1,000. Why am I over 1,000? Because I'm in centimeters cubed. And it's asked me to calculate the concentration. So I'm going to have to reorganize this. Never learn, ever learn a rearrangement, folks. Just learn to rearrange. Moles times 1,000 equals C times V. And then bring the V down. Yeah, there we go. So there's my rearrangement. Over V gives me C. Right, now all I need to do is now input my numbers. So I've got moles of 0.1 times by 1,000 all over a volume of 200, and I get, well, not particularly, it's 5 over 1. It's basically times 5, right? 0.1, yeah, 0.1. By the way, I know I do it on the calculator. I do. Yeah, 0.5. So the answer there is going to be equal to. Now we're going to do, I'm doing a shout out for my mate Dave. Mate Dave. Oh, Dave. Yeah, my mate Dave back at home has been watching my YouTube videos. I spoke to him yesterday. It was very embarrassing. And he was like, well, you didn't give it to 3 significant figures. So 3 sig fig would technically be that guy. Yeah, that's moles per diem cubed. There we go. Yeah. Hi, Dave. Dave, you just got a shout out from Lara. That's amazing. Love it. Yeah. Okay, next. So we're doing the same process. Now, I'm just going to kind of reuse it. I really probably shouldn't do that, to be fair, but number of moles times 1,000. I don't like it. Number of moles equals C. I can't do it. I don't want to learn a rearrangement, because if I do, in an exam, I will make a mistake. Moles times 1,000 over V gives me C. I'm just rearranging it again. I know people are like, what are you doing? It's so weird. Let's input my data. We've got 0.2 times 1,000, because I'm in cm cubed, yeah, over a volume of 100. It's the same as times by 10. 0.2 times 1,000 divided by 100 gives me 2, and I've got to give it to 3 significant figures, yeah, which is going to therefore be 2.00 moles per dm cubed. Yeah, so I'm all right with that. By the way, the reason why he was like saying, oh, well, you haven't done 3 significant figures in your first question. You were having a, what did triangles ever do to you? Oh, no, Ananya, I can tell you what it's about. The reason being is when I pick up my A-level students, the first thing that they get hit with is more equations. By the way, there aren't that many, just to make you feel better. Yeah, I can actually mention the A-level bit today in gases, because it's actually a gas translation. But the point is when you get more than 3 people, the triangle falls apart and they end up making a right mess of it. And you can't do it. They'll pick apart your triangles. So you just need to just not do it. It's better understanding if you can rearrange. It's better. Yeah. Dave's a physicist, by the way. That's why he's a stickler for 3 sig fig. Next, Number of moles equals C times V over 1,000. Rearrange number of moles times 1,000 over V gives me C. Input my data, 0.025 times by 25. No. You see, that's why. Times by 1,000 over 25. Going to do that on a calculator. It's going to take me, it's 1. Is it 1? It's 1. 0.025 times 1,000. That just brings it to 25. Moves the decimal place row and then divide it by 25, which is the bond we'll get, and we get to 1. Yeah, the concentration is 1 mole per dm cubed. 1 mole per dm cubed. Does everyone agree? He's a physicist? Yeah, he's a physics teacher. Yeah, that's cool. Right. So is everyone okay with this? Yeah, seem reasonable? Right, next one, of course, they've just, number 2's gone on to a rearrangement. Nice and easy. Yeah. So they've gone, okay, so number of moles. So what are they asking you to calculate the number of moles? Ah, yes. Why is it 3 sig fig in the answer, but 2 in the question? Wait, I got 0.8. Oh, what did I do? What did I do? 0. Oh, thank you. No, I apologize. I've written a mistake in. Look. Oh, my laptop's being a bit slow. Look, I'm sorry. There you go, folks. I just translated it over wrong. Yeah, it's early in the morning. There we go. I'll fix that. There we go. That's better. 0.020 times by 1,000. Divide by 25. I apologize. It's not. It's 0.8. Thank you. 0.8 moles per dm cubed. I apologize. There we go. Fixed. Just a translation error. Yep. I'm going to try and... Sorry, my laptop's being a bit sluggish. Okay, calculate the number. So this one's nice and easy because it is the equation that we know and love, C times V over 1,000. Yeah. And why have we got the 1,000? Because we're in centimeters cubed. Yeah, so the 1,000's there. If we were in Diem, that 1,000 vanishes. Yeah, nice and easy. So input my concentration. There's my concentration. Moles per dm cubed. That's the key bit there, folks. Yeah, that says concentration. That's the hard bit. Got to recognize your units. Here's your volume. Yeah, so input my data. 0.20 times by a volume of 100 centimeters cubed, all over 1,000. Yeah, it's the same as divide by 10. 0.20 times by 100, all over 1,000. Gives me 0.02 moles. Right, by the way, I did have a question there, which was, why is it 3 sig fig when the question's only in 2? That's a really good question. So the reason why, who said it? Libby. The reason why is, do you notice that the question itself, here's the actual question, yeah? And the question hasn't actually stated how many significant figures it wants the answers in, yeah? Now, I know that you'll get various people who will say to you guys, what are you doing, stupid computer? There we go. I know that there are lots of, like physics, for example, they'll say, you can't give more units than are in the question. The rule of thumb is in chemistry is to give your answers to 3 sig fig. It's just, and I realize, by the way, he's going to sting me for all of these because I haven't done it, have I? Technically, it'd be like this. I know I'm not even being particularly consistent. I know that I don't want to get overly stuck on this. Yeah, so 3 sig fig. No, the problem is significant figures would actually be there, would actually be that. No, it would actually be that. That's 3 sig fig, not 2 decimal places. That's technically correct, Ananya, but I don't want to get overly stuck on this. That's a common sense answer in chemistry, and I don't want you to overthink this. The rule is 3 sig fig, but it's just, it's not something I really want to be this is not my focus of the lesson. I'm not focusing on significant figures here. I'm just focusing on the chemistry. Okay, next one. Number of moles. Do you notice, year 10, I have written down the equation every time. And I'm doing this because I've been teaching chemistry for 15 years. And I still do that every question because it reinforces it in my head. It means that I don't have any of those doubts. Concentration, 1.5 times by a volume of 25 all over 1,000, and I get a number of moles of 1.5 times by 25 all over 1,000, and I get 0.0375 moles. Mole. Next, number of moles equals C, 0.1 times by V, which is 50 all over 1,000 because I'm in centimeters cubed. 0.1 times by 50 divided by 1,000 gives me 5 times 10 to the minus 3. And I'm done, standard form. Cool, next, okay, on to the next one. Calculate the concentration of the following solutions in grams per dm cubed. Okay, nice easy translation here, folks. This actually, and look, they've actually told you it. I don't really like what they do there. Like, I feel like there's no explanation in that particular picture. Yeah, I'm just going to zoom out just a little bit. So we're going from moles per liter to grams per liter. Well, what you realize is the per liter isn't changing. What that means is I just need to go from moles to grams. And that is grams over rams. Number of moles is grams over rams. But I'm trying to get to grams. So I'm going to rearrange this. I never learn a rearrangement. I just reorganize every time. Bring the rams over. Rams times moles gives me grams. Right, so I just need to multiply these by the relative molecular mass or relative formula mass, depending. So the first bit on this question is, what's the MR of this guy? So I've got sodium on the periodic table as 23. As 23. Oxygen is 16 and hydrogen is 1. Total number is 40. Yeah, 40. Is that right? Yeah, it is 40. 23 plus 16 plus 1. Yeah. Oh, bloody yeah. 23 plus 16 plus. I always got to check. So we've then got multiply that by 0.100. Notice 3 sig fig. Yeah, it gives me 4.00 grams per dm cubed. Is everyone okay with that? My laptop keeps going to sleep. There we go. Next. So once again, work out the weight. Vinegar. That's ethanoic acid, by the way, otherwise known as acetic acid, otherwise known as vinegar. So we've got carbon at 12. How many carbons do I have? I've got 2 of them. Yeah. I'm going to add that to hydrogens, which is 1. But how many do I have? I've got 4 times by 4. And then I'm going to add that to oxygen, which is 16 times how many? 2. So I think it's going to be 60. Yeah, 12 plus 12 plus 4 plus 16 plus 16. 60. Total is 60 for 1 mark. There's the number. Got to remember, people are cheating. Be careful. So I'm going to have, my number now becomes 0.250 multiplied by 60. Multiplied by 0.250 gives me 15.0 grams per dm cubed, 3 sig fig. There we go. And that's a point, by the way. Next, right, nitric acid, hydrogen 1 plus nitrogen 14 plus oxygen 16 times 3. So 1 plus 14 plus 16 times 3 gives me a number of 63. There's 1 mark. 1 mark for 63 for its relative molecular mass. That's by the way, this one is the RMM. That's molecular mass because it's covalent. This is RMM because it's covalent, molecular. But this is RFM, relative formula mass, because it's ionic. Just nice to throw in that little level of detail. Yeah, and then you go, oh, right, I need to multiply that by the concentration. So times by 1.5. Yeah. So 63 times 1.5, and I'm going to get an answer of 94.5 grams per dm cubed. And we're done. Next. Okay, so what have they now done? Oh, made it much harder. So number of moles is C times V over 1,000, straight off the bat. Yeah, and then it said calculate the concentration in moles per dm cubed. So it's asked me for the concentration. Reorganize, bring that up, bring the V down. Number of moles times 1,000 divided by volume gives me C. Right, let's run it in. So number of moles, which is 0.2, times by 1,000 over a volume of 250. Why is the 1,000 there? Because we're in centimeters cubed. Surprise, surprise. I haven't had anyone say anything on the chat recently. 0.2 times 1,000 divided by 250 gives me 0.8. So we get 0.800 moles per litre, moles per dm cubed. Right, now we're going to go from grams to dm cubed. That's nice, just a simple translation. Multiply it by the MR, because number of moles is grams over rams. Reorganize it, moles times grams gives you rams. Gives you, you shouldn't do that. Moles is grams over rams. I want grams. Yeah. Moles is grams over rams. I want grams. There we go. Reorganize. So I'm going to multiply that by the relative molecular mass, which is 40. We've already done that one. That's nice. 0.0800 times by 40 gives me, times by 40, 32 grams per liter, grams per dm cubed. Cool. Winner. Next. Okay. Now, guys, you've got a choice now. I'm actually going to go the easy route. I like to think that you guys have spotted that they've just flipped it over. Yeah. And so I'm going to do the moles ones first. Yeah. So I shouldn't really, but I don't want to go that. I did it on the previous year 10 lesson, and I think I regretted it. So I was like, oh, I might not do that. I'm going to turn off one thing. I think it's slowing my computer down. Go away. Close OneDrive. There we go. So I'm going to do moles per dm cubed. Number one, we've been given grams, folks. So number of moles, grams over rams. Right, so I can get it to moles. 5 divided by, what does potassium nitrate weigh? Well, potassium is 39, nitrogen is 14, oxygen is 16 times 3. I know I've learned them. I've just been dealing with them for so long. They're just in my head. Plus 14 plus 16 times 3 gives me 101. 101. So 5 over 101, it's going to give me grams over rams. Gives me 0.0495 moles. So now I can do moles per litre. So I'm now going to go number of moles is C times V over 1,000. Why am I over 1,000? Because I'm in centimeters cubed in the question. Right, input my data. So I've got reorganize, bring the 1,000 up, volume down. So number of moles times by 1,000 over volume gives me concentration of moles per dm cubed. So I've got number of moles, which is 0.0495, multiplied by 1,000, divided by 100, which gives me moles per dm cubed, 0.495 moles per dm cubed. I like it. Next, how do I now get that to grams per dm cubed? Okay. So number of moles is grams over rams. I want grams reorganized. Times it by the relative molecular mass. How much potassium weigh? 101. Times by 101. Times that by 101. And gives me 50. 50 grams per litre. And I'm done. If you wanted 3 sig fig 50.0, if you like, I'm going to get pigged by. He's going to be like, you're throwing consistent. He really will. Dave's going to have a go at me. It's funny. Right, that brings me to the end of the solution homework. I hope you guys got on okay. For the next one, for the gases, folks, I can't remember whether or not I'm actually going to, on the next one, I want to, hang on. I just want to have a look at what I sent you guys. Turned in. Only 1 people turned it in. Oh, but the answers were there. That's why. Right. Year 10. I'm going to be giving you the gases one. I'm going to be giving you the gases one as a homework. And I'd like you to do what Dom had already done. You know, Dom turned it in, and that way I'll be able to actually, I don't know how I actually look at this. Like, I actually don't know. I've not actually done this before. I don't, do I just click on that bit? Turned in. Yeah, but how do I say no work has been attached? That's really funny. If you guys could do me a massive favor and no work turned in, and can you submit, it just means that I can do an assessment with it. I won't post the answers. I'll just give you the questions and you can have a go. Cool, right. Okay, so today's lesson. Guys, today's lesson is moles and gases. Yay. Title, moles. I'm going to make it a bit bigger. Moles and gases. Moles in gases. I'm doing a mole in gas. There we go. He's not very good, is he? I seem to have no. It's just not very good. I need to make his belly's going to be shorter. Yeah, I need to make his belly shorter. No, it's still too long, and his tail's then too long. There we go. He's not very good today. I'm so disappointed with Molly and Gas. I'm so disappointed. I feel like it's that bit that's causing me the problem. Oh, I don't know. I've ruined it. I've ruined it. Oh, I used to be so good. Wow, I'm really not. I've made a mess of that guy. My other one was better. I'm really disappointed. He actually looks a little bit evil. Have you seen him? Look at him. He's looking a bit evil. He's terrible. I'm better than that. I'll work on that, folks. I'll do a poster of moles and gases. But anyway, we've got moles and gases. So let's do some learning objectives. Number 1, I need you guys to know number of moles is V over 24. And I'm going to put in brackets Diem cubed. Yeah. Where are his eyes? Under his whiskers. Yeah, I know. It's tricky, innit? Yeah, let's just ignore him for a minute. So we've got moles is V over 24, and that's in Diem cubed. Yeah, I need you to understand ideal gases. Ideal gases, and I need you to be able to use apply V over 24, number of moles equals V over 24 and V over 24,000. I'll explain in a minute. Yeah, okay. So what we need to realize is I need to talk to you guys. So historically, okay, I'm going to get rid of it. I'm just going to leave him floating now. He's gone. He's gone. I don't like him. He wasn't as good as my others. Okay, so let's do equation. Number 1, I don't want it in a triangle, folks. I don't. Yeah, number of moles in gases equals volume of the gas in Diem cubed over 24. Now this is called a gas constant. Now just to tell you, chemists don't read, that is the equation, yeah? But the thing is, chemists really don't, really? Diem? Nah, not really, folks. We work, in general, we work in centimeters cubed, which means there's an alternative equation. Number of moles is V in centimeters cubed over 24,000. Yeah? And it's just a simple conversion. That's all we're doing. Yeah? But I'd actually recommend, by the way, just to let you know, they tend to give you this number in the exam, which makes things a whole lot easier. I wouldn't recommend you learning it, but it's useful if you do, but they usually provide it in the question. Yeah, partly because of this centimeters and milliliters issue. So they tend to just give you them. I don't know why. I guess it's just a value, so they don't really care about you learning it so much. So I need to explain where this comes from, because the big question is, why 24? Yeah, so the question here, this is called an ideal gas equation. Yeah, a gas constant. The question is why 24? Diem. Why 24? I can tell you why. The reason being was, a couple of hundred years ago, a very famous chemist called Lavoisier was absolutely obsessed with gases. And he made a rather startling discovery. Because he was obsessed with gases, what he basically did was he liked to make them, and he liked then to investigate what they were about. So what he did was he made a whole load of gases. Yeah? So he made balloons of gases. Now what I'm going to do is I'm going to do what you guys can't hear, which is I'm just going to go like that and then go, hang on. Copy. Paste. Yes. There we go. So he made a whole load of gases. And I'm going to add another one. Paste. And then move that up as well. There we go. Going to do one more. Paste. Why not? Yeah. So what he did was he created lots of different gases and then he weighed them. So he made a balloon of hydrogen. Yeah. And he made a balloon of carbon dioxide. And he made a balloon of nitrogen dioxide. And he made a balloon of oxygen. Oh, blimey, flipping out, ozone. No, oxygen. There we go. So he made these balloons of different gases. And what he did was he made them, he did a really clever trick, which is he made all of them the same size. He made all of them the same size. Now, what he discovered was that when he measured their size and their weights, when he had 2 grams, when he had 2 grams of hydrogen, the size of the balloon was 24 liters. When he had carbon dioxide, to get 24 liters, he needed 44 grams of it to give him 24 liters. And then to do nitrogen dioxide, it's hang on. He got 46 grams and it gave him 24 liters. And then with oxygen, to get 24 liters, he only needed 32 grams. Can everyone spot what Lavoisier now discovered? Because the question is now, what are these quantities? And this was one of the most important facts I can ever teach you, year 10 for chemistry. Yeah, that is such an important fact. What have I just given you there? Grams over rams. Grams over rams. Right. So 2 grams over the relative molecular mass of 1 mole is all the same. Yes, well done, Haoping. Yeah, 2 over 2 gives me 1 mole. Yeah, I have 1 mole of hydrogen. I have 44 grams over the relative, which is 12 plus 16 times 2, which is 44. Yeah, that weighs, carbon dioxide weighs 44. That was 1 mole of carbon dioxide. And then this one is 46 over a relative molecular mass of 46, which was 1 mole. And oxygen, which is 32 grams over 32, the relative molecular mass of oxygen. And what did I get? I get 1 mole. He made a startling discovery, which is 1 mole of any gas. And this is such an amazing discovery. Yeah, fact. And you need this, folks. 1 mole of any, underline, any gas occupies 24 Dm cubed. It's amazing. Magic. What an amazing discovery. It doesn't matter what the gas is, as long as the gas is ideal. So an ideal gas. An ideal gas is a gas that behaves like gas. Isn't that really funny? An ideal gas is a gas that behaves like a gas. As long as it's above its boiling point. What about when you heat the gas? Oh, yes! Great job, Libby. 1 mole of any gas occupies 24 Dm cubed. Can you please add this, please? At, oh, I am so cool. Look at me. Look at that. At 25 degrees Celsius. Thanks, Libby, you star. You've got to have it at a fixed temperature because we know that gases expand or contract when they're heated or cooled, respectively. So an ideal gas is a gas well above its boiling point, nowhere near its boiling point, because you don't want it to start behaving like a liquid. Gas well above boiling point. Because if you're close to it, it's going to start behaving like a liquid and it's no longer an ideal gas. Yeah. It's cool that. Well done, Libby, for spotting the temperature. Good job. But look at that. Isn't that just beautiful chemistry? I just think it's amazing. And this guy was making all of this himself. It was amazing. The guy was a hero. Lavoisier. He was also a French tax collector. We chopped his head off. It took us about 150 years to make another good chemist like him. Yeah, that was very sad, that. Very sad. Antoine Lavoisier. That's his name. Right. Okay. So now that we understand this, we can just go straight into questions. Agreed? This isn't complicated. We now know the equation. We understand the ideal gas is one that needs to be way above its boiling point. Yeah. And we now need to apply this. And I've also done the translation as well to the V over 24,000. Yeah. So let's now do some questions. This isn't complicated today, folks. It's not complicated. It's not complicated. Question number 1. I'm going to give you 2 Dm cubed of CO2. Question. How many moles? How many moles? Nice and easy. Off you go, folks. Pause the video and have a go at the question. When you are ready, you may resume the question. Okay, number of moles is V over 24. Why am I doing over 24 here, folks? Why over 24? Because I was given Dm cubed. Yeah? Rearrange it. Oh no, I'm after moles. Don't even need to rearrange it. Number of moles is 2 over 24. Nice and easy. And I get 0.0833 moles of carbon dioxide. Someone okay with that? This isn't complicated. Question number 3. That's question number 3. Question number 2. Lol. I'm going to give you, I don't know, 10 moles. 10 moles of oxygen, of O2. What volume? What volume? What vol of O2 do I have? I'm going to just put vol question mark. Right, it's asking me to rearrange. Number of moles equals V over 24. I never, ever learn a rearrangement. I learn one equation and then reorganize. Times by 24 gives me volume. What units of volume will I be spat out in? I'm using 24, so I will be in Diem cubed. Therefore, 10 times 24 gives me a volume of 240 Diem cubed. I'm doing my best elevator voice here, folks. What do you think? Next question. Right. Now, folks, you realize that this is not complicated. This is not complicated. It's not complicated. So how do they make this complicated at GCSE? This is really easy. Right, guys? I'm going to give you 100 grams of carbon dioxide. What vol of CO2 do I have? Go on, folks. Impress me. Please pause the video now and then resume with your answer. Right. So, I've been given grams. Guys, what you now start realizing is all of these equations are going to start pulling together. Yeah? We now have 3 moles equations. Number of moles is grams over rams. Number 2, moles equals C times V over 1,000 when I'm in centimeters cubed. And I now have number of moles is V over 24 when I'm in Diem cubed. Yeah, there we go. So we've got these 3 equations, and which one am I now going to use? I've been given grams. So I'm going to go number of moles is grams over rams. What's the rams of carbon dioxide? I always get off on the periodic table, which is 12 plus 16 times 2, which gives me 44. So I'm going to do grams over rams. 100 over 44. Oh, no, I've gone Yorkshire again. 100 over 44 gives me 2.27 moles. There we go. Right, now I've got moles. I can now use V over 24. Yeah, I've got moles and I've got 24. Bring it over. Number of moles times 24 gives me V. Right, well, I just put in that number there. You realize you're going to start combining these, folks. Yeah, 2.27 times by 24, and I get a volume of 54.5 Diem cubed. I'm in Diem cubed because I use 24, not 24,000. Winner. Cool, that. Amazing. Right. Question number 4. Are you guys with me so far? I know this is getting harder by a minute. Question 4. Right. So you guys know that, of course, I get liquid nitrogen into school as often as I can. You guys know that? Yeah. And I buy 10 Diem cubed of liquid nitrogen. So you can't use V over 24 because the volume is for a liquid. It's not a gas. So I buy, so Mr. Duncan, what time is it? Mr. Duncan buys 10 Diem cubed of liquid nitrogen. Yeah, so I can't use V over 24 because it's not an ideal gas. Yeah, but what I can do is tell you that the density of liquid nitrogen is 0.89 grams per centimeter cubed. Right. So what I can now do, by the way, I'm going to put the question out. This is a very much a differentiation, guys. See if the people who really want to have a go at this on their own with no help, please have a go now. Here's the question. So that 10 Diem cubed, which I buy in a Dewar's container, yeah, my Dewar's container, which you guys have all seen. It's really cool. Yeah, my Dewar's container looks like this. Yeah, my 10 liters, yeah, which is inside it, being kept cold. Yeah, my 10 liters of liquid nitrogen, which is all here. Yeah, I buy 10 Diem cubed. What if I turned that all to gas? what volume will it occupy? Yeah. So at room temperature, what volume will that liquid become? So this is very much a differentiation, folks. What I'm going to do is I'm going to stagger this. So obviously, if you want to have a go straight off the bat, please pause the video now and you can get going. If you want a bit of help, I can talk you through the first few steps. Okay, so first few steps of this question. So number one is I've been given density because we know in order for me to get to moles, I've got three equations: grams over rams, C times V over 1,000, and number of moles. Number of moles is V over 24. Sorry, my other laptop keeps going to sleep and I keep having to wake it up again. So number one is, can I use any of this data? The answer is I can't. The volume it's not a gas, so I can't use that yet. But I do have the density of this liquid. What this now means is I can turn it into grams. So number one is I've got a liter and this is grams per centimeter. Yeah, so I need to turn that into centimeters, times it by 1,000. So that's now going to be 1,000 centimeters cubed. Agreed? Right, if you want to now have a go, please pause the video now and see if you can continue. So I'm going to move that down to here. Step one, 10 dm cubed equals 10,000 centimeters cubed. If you want to have a go, pause the video for the next step. Yeah. Next, so the second step, that was step one. This is the steps in answering this question. Step two is I now need to turn that liquid volume into grams. Well, hang on, folks. Each centimeter cubed weighs 0.89 grams because that's per centimeter. So what I now need to do, step two, is to take that 10,000 and multiply it by 0.89. Yeah, the mass of each centimeter. So 10,000 multiplied by 0.89. Yeah, which gives me 8,900 grams of liquid nitrogen. Agreed? Right, now, if you like, before I do step three, you can pause the video, have a go at step three now, and then go to and continue that way. If you're still not sure, continue watching. So step three. I've now got 8,900 grams of liquid nitrogen, N2 liquid, which means now I can do grams over rams. What does nitrogen weigh? Nitrogen weighs 14 on my periodic table, but it's in a pair. It weighs 28. So I'm going to divide that by 28. This is now going to give me moles. Divided by 28, grams over rams. I've got 317.9 moles. Right. Now I can use the ideal gas equation. I can use V over 24. So now I can do step four is number of moles is V over 24. Well, I've got moles, and I've always got 24. Reorganize. Number of moles times by 24 will give me the vol. So there's my moles multiplied by the 24 gives me, I'm gonna get 7,628 dm cubed. Guys, so let's just now consider what that's just said. I have just gone from 10 dm cubed of liquid nitrogen, and it has now turned into nearly 8,000 liters of gas. Isn't that insane? That's how much nitrogen I have in that container. 7,628 liters of gas. That's crazy. Yeah, that's why, by the way, we always store gases as liquids. Store as liquid. Always. Because otherwise you need a container that's either this big or that big. I don't know about you. Would you round up? Okay, 3 sig fig, sure. 7630 Diem cubed. If it was 3 sig fig, yeah. Yeah. Anyway, isn't that cool? Isn't it amazing? Guys, amazingly, that's the end of our lesson. Wow, gases are done. Oh, guys, moles in gases are done. So we've now done moles in solids, moles in solution, and moles in gases. Guys, we've done them all. We have all the moles. What that means is we can now start playing around with these things, and I can start giving like some wicked cool questions, which will blow your mind. Right, guys, I am gonna love you and leave you. Go and have a nice break. But it's been so great to see you, Year 10, as always. You guys are just brilliant, and thank you so much for coming along. I hope you guys have had a lovely weekend and you're all staying safe. And it's great to see you guys. Take care of yourselves. I'll see you next lesson. I'll see you tomorrow. Bye, guys.